હવે જો આપણે photoelectric effect discuss કરી, in that we studied this thing. In photoelectric effect we can observe this thing when the radiation or the light with sufficient frequency incident on the metallic surface, then the electrons are emitted from the surface. And experimentally we observed this thing. The number of electrons emitted from the surface, that depends on the intensity of the incident radiation. Means that photoelectric current, that depends on the intensity of the radiation, and the maximum kinetic energy with which electrons are emitted, that depends on the frequency. And this particular phenomenon, that is instantaneous one, means as soon as the radiation, or we can say light incident, within the time interval of nanosecond, the electrons are emitted. And here the radiation, that must be with some minimum frequency. So the frequency, that is called threshold frequency. If the incident radiation have the frequency less than this threshold frequency,
Sir, full screen kar raha.
then the radiation will not be, that will not be able to emit the electrons. Okay. So if the frequency of the incident radiation is less than that minimum value of the frequency, which is called threshold frequency, then the photoelectric effect is not observed. આવું બધું આપણે experimental study કર્યા. Okay. લેનાર્ડ અને હોલવાસના experimental observations થી આપણે આ બધા conclusions લઈ આવ્યા. Okay. Then after, when they tried to explain this particular phenomenon with the help of the established fact, the light have wave nature. So by considering this fact, when scientists tried to explain this particular phenomena, then they totally failed. It implies that wave nature of light totally failed to explain this particular phenomenon, photoelectric effect. Okay. Then after scientist Einstein gave the explanation for this photoelectric effect. Actually, before that, the concept related to the quanta of energy was represented by Planck. Planck suggested this thing when he studied about, or when he tried to give the explanation about the black body radiations. So he suggested this thing, the radiation emitted, or we can say the energy emitted in black body radiation process, that is in the form of quanta of energy. And the minimum quanta of energy, that is equal to hf, or we can say h nu, where h is Planck constant and nu, that is the frequency of the radiation. So radiation is made by different quantas of energy. Means radiation possesses the energy in the integer multiple of hf. And this particular quanta of energy, that is known as photons. Known as photon. So continuous emission of the energy is not there. Energy is emitted in the form of quanta, hf, 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 like that, or 2hf or 3hf. So it is always in the integer multiple of hf. So energy that is emitted equal to nhf, where n, that is integer, 1, 2, 3, 4, like that. But he suggested this thing, energy is emitted in the form of quanta, and then after it propagates in the form of wave. But actually, this one was controversial because classical mechanics says this thing, if we consider any oscillator, then it can possess any energy from maximum to minimum. And here, the quanta of energy, that is against the classical mechanics. એટલે એ થોડું કન્ફ્યુઝિંગ થઈ ગયું હતું એ વખતે. પણ પછી એ જ કોન્સેપ્ટને આઇન્સ્ટાઈને થોડો આગળ ડેવલપ કર્યો. આઇન્સ્ટાઈને ત્યાં સુધી કીધું કે light means radiation incident in the form of quanta, it interact with the electrons in the form of quanta, and the emission that is also in the form of quanta. Okay, તો આ રીતનું આખું એણે એક્સપ્લેનેશન આપ્યું. હવે એણે જે એક્સપ્લેનેશન આપ્યું એનાથી ફોટો ઇલેક્ટ્રિક ઇફેક્ટ કેવી રીતે પરફેક્ટલી એક્સપ્લેન થઈ. ઓકે, so he suggested this thing, when the radiation which possesses the quanta of energy, that is h nu, or we can say hf, where h that is the Planck constant and nu or f that is frequency of the radiation. Okay, so when that particular quanta of energy incident on the metallic surface and interact with the electron, so if this particular energy is greater than the work function of the metal, then electron will be emitted, otherwise not. Okay, now see, if this particular energy is greater than work function of the metal, then electron will absorb this entire one. Very first thing, એમાં એવું નહીં કે એમાં પાર્ટલી એબ્સોર્બ કરે કે એવું નહીં, આમાં બે જ વસ્તુની પોસિબિલિટી, રેડિયેશન એટલે કે ક્વોન્ટા ઓફ એનર્જી ઇન્સિડેન્ટ થયું, આઈધર ઇટ વિલ બી એબ્સોર્બ્ડ ઓર રિફ્લેક્ટેડ. જો રિફ્લેક્ટ થઈ ગયું તો પછી એની સાથે કોઈ લેવા દેવા નથી આપણે, એબ્સોર્બ્ડ તો પછી એન્ટાયરલી એબ્સોર્બ્ડ. બરોબર છે? તો હવે h nu energy of the quanta is greater than the work function of the metal, then the energy equal to work function of the metal that will be utilized to be free from the metal. અને જો exactly work function જેટલી જ એનર્જી વાળું રેડિયેશન ઇન્સિડેન્ટ થયું હોય અને એ એબ્સોર્બ થઈ જાય તો ઇલેક્ટ્રોન ફ્રી થઈ ગયો મેટલથી, but now we can say it is with zero kinetic energy. પણ જો વર્ક ફંક્શન થી વધારે એનર્જી એબ્સોર્બ થઈ તો વર્ક ફંક્શન જેટલી એનર્જી ફ્રી થવામાં યુટિલાઇઝ થાય, and rest part of the energy that will be possessed by electron in the form of kinetic energy. So we can say this thing, when h nu is greater than 50, then electron will be emitted with maximum kinetic energy, that is h nu minus 50. And this particular equation, that is called Einstein's photoelectric equation. Okay, now see, here we can observe this thing, the maximum kinetic energy that linearly depends on the frequency of the incident radiation, and it is independent of the intensity of the radiation. So this one is in perfect agreement with the observations. Clear? And here we can observe this thing, if the frequency of the incident radiation is less than a particular frequency, that is the threshold frequency nu 0, that is 50 by h. Because 50, that is the work function. Work function means the minimum required energy to make electron free. So energy, that is h into frequency. Okay. So minimum required energy, that is associated with the minimum frequency, and that is threshold frequency. So we can write nu zero, that is 50 by h. Okay. Now see here, we already discussed this thing, K maximum, that is equal to EV0. So we can write EV0, that is h nu minus 50, where nu is greater than nu zero. So we can write V0, the stopping potential, that is h by E into nu minus 50 upon E. So if we draw the graph of stopping potential versus frequency, then that will be the straight line, and slope of it, that will be h upon E. And this one is also in perfect agreement with the observations. Then after, if we think about the intensity, see what is the definition of intensity? So amount of energy incidenting on the surface per unit area per unit time normal to it, that is called the intensity of the radiation. Okay. હવે intensity અને photoelectric current, એ બે એકબીજા સાથે એસોસિએટ છે, આપણે ડિસ્કસ કર્યું. If intensity is more, the photoelectric current is more, એટલે કે number of electrons emitted will be more. તો હવે જો એનું એગ્રીમેન્ટ અહીંયા પરફેક્ટ કેવી રીતે આવે છે? Now radiation, it is made by quanta of energy. હવે જો રેડિયેશન સપોઝ કે બે ક્વોન્ટાનું બનેલું હોય તો 2hf એનર્જી ઇન્સિડેન્ટ થાય, રાઈટ? તો માનો કે ઇલેક્ટ્રોનને hf જેટલી અથવા તો h ન્યુ જેટલી એનર્જી એક ઇલેક્ટ્રોન એબ્સોર્બ કરે છે. તો રેડિયેશન તમારું બે ક્વોન્ટાનું બનેલું હોય તો બે ઇલેક્ટ્રોન એબ્સોર્બ કરશે ને બે ઇલેક્ટ્રોન એમિટ થશે. If your radiation is made by 5 quanta of energy, each one is with energy h nu, તો પછી 5 ઇલેક્ટ્રોન એને એબ્સોર્બ કરશે અને 5 ઇલેક્ટ્રોન એમિટ થશે. It implies that if the number of photons, or we can say number of quanta of energies, increases on the incident surface, then we can say its intensity increases because amount of energy incidenting increases. And corresponding to that, more number of electrons will be emitted. So the dependence of the number of electrons emitted from the surface on the intensity, that can be perfectly explained with the help of this equation also. So finally, it was established, Einstein's explanation was perfect one, and it was accepted there is the duality in the nature, and in some favorable conditions, wave behave as a particle. And this particular particle nature of the wave, that is known as photon. So this quanta of energy, that is known as photon. Clear? And this quantization also proved by Millikan experimentally. Okay. So quantization exists in the nature. Clear to all of you, or any doubt in this one?